Hi, my name is Kristen Gardner. I'm a rising junior and Chancellor Science Scholar majoring in biochemistry. Fun fact, I love to bake cookies, and I'm interested in mentoring Chem 101. I previously mentored Freeman's Chem 101 class this past spring, and so I'm going to walk you through one of those problems. It's a titration problem. And so first, when you're balancing an equation, what I always tell people to do is look for things that only appear on one side of the equation. So for example, calcium only appears on one time on each side. And so there are 3 calciums here, so I'm going to need 3 calciums on that side. I can do the same thing with the PO4 because there's only one of those on each side. So there's 2 over here and 1 over here, so that means I need a 2. Everything else repeats. So first I'm going to look at hydrogens. There are 6 hydrogens here and 6 hydrogens here, so that makes 12. On this side there are only 2, so I need to add a 6 in order to get to 12. And then finally I'm just going to check my oxygens. So there are 6 here and there are 6 there, so it should be all balanced. And if you want, you can put a 1 here because you know that you didn't need to change the number in front of this and the part of the equation, but you don't have to. And then the next part is determine the concentration of phosphoric acid. So you want to determine how much of H3PO4 there was. Remember that molarity is equal to moles over liters. And so what we need to do is look at what we already have. So finding the molarity of H3PO4, we already know that there was 0.1 liters of phosphoric acid. And in addition, we know that we used 0.05 liters of calcium hydroxide and 3 molar calcium hydroxide. So when you do a titration, you need it to be 1-to-1 ratio. And so my first step is to convert this calcium hydroxide that we concentration and amount into moles. And so we can do that by saying you have 0.05 liters of calcium hydroxide that was needed to titrate this. And you know that there's, if it's a 3 molar solution, that means that there is 3 moles per 1 liter. So that means you have 3 moles of calcium hydroxide for every 1 liter. Now we've canceled out liters. The next step is to get to moles. So right now we have moles of calcium hydroxide, but as I said, we're trying to find the concentration of phosphoric acid, which means we're going to need moles of phosphoric acid. And we can convert moles of calcium hydroxide to moles of phosphoric acid by looking at the chemical equation. So we know that we have 3 moles of calcium hydroxide for every 2 moles of phosphoric acid. And so now if we look, we've canceled out moles of calcium hydroxide and moles of calcium hydroxide here. And now all we need to do is convert to molarity. So as I said before, molarity is equal to moles over liters. So the final step is just to use the amount of liters we have of phosphoric acid, which as I said before is 0.1 liter. So now you've canceled out liters and moles of calcium hydroxide, and you're left with moles of phosphoric acid over liters of phosphoric acid, and that will give you a molarity. So if you multiply all the top numbers by all the bottom numbers, you're going to get 1 mole of H3PO4 for 1 liter of H3PO4, which is going to be equal to 1 molar. So now you know that the concentration of phosphoric acid is a 1 molar solution.